Okay, so giving the data set, the sample data set. Now is a sample data. Okay, so 1, 2, 4, 6, 7. Now find the sample variance and standard deviation. Okay, try it by yourself. I give you guys 1 or 2 minutes. Try it. Now we have the sample data set, right? So definitely we're gonna use the different formula for the population, right? Especially for the sample variance. Did you finish it? Huh? I'm sorry about that. Wait, 4 steps. We did 2 examples. I'm gonna wait a little bit more. and then we're going to do it together. Okay? Okay, I'm gonna show you guys the results. Okay, show you guys the results. So the first step, calculate the x bar. All right, calculate the x bar. X bar gonna be the mean value. The summation of all these values are gonna be 1 plus 2 plus 4 plus 6 plus 7. And divided by how many? 1, 2, 3, 4, 5. Okay, divided by 5. And you're gonna get how many?
4.
4. Aha, good job, good job. Now the second step, we're gonna calculate the deviation. Second step, we're gonna use the table, right? We're gonna use the table. X minus x bar square. So second step and the third step. So we have 1, 2, 4, 6, 7 as for x. And after you calculate the mean value, then we do the subtraction. 1 subtract 4 gonna be a -3. 2 minus 4, -2. 4 minus 4, 0, 2, 3. Right? So that's the deviation. And for the square, gonna be a -3 square, gonna be 9, 4, 0, 4, 9. Okay. And now we can calculate the summation or sum of the square. That should be do the addition. We have 26. Okay, we get 26. Now, for the first step, we can plug in everything in the formula, calculate the sample variance. Sorry, calculate the sample variance. And it should be S squared equals summation divided by what? N minus 1. Okay, be careful. It's N minus 1. It's not capital N. Okay, so it's the number of data set minus 1. And we know this guy is 26. How many? 1, 2, 3, 4, 5. And the result's gonna be 6.5. Oh, sorry. Yeah, 6.5. Yeah, 6.5. That's good. That's good. And the sample standard deviation, and this guy gonna be S equals the square root of this guy, and then we do the square root, and then this guy will give you the answer is 2.55. Okay, 2.55. But that's it. That's it. Okay, so that's a typical way, 4 steps to solve the sample variance and the standard deviation. Okay, and more questions should be assigned through your homework. Okay, through your homework. I'm gonna assign a lot of homework related with such problems. Okay, today we're gonna learn something new. We're gonna learn something new. The standard score. Okay, it's very important. The standard score, a z-score. Definition. The standard score or z-score represent the number of standard deviation a value x lies from the mean value mu. To find the z-score, for our value, use the formula, this guy. The formula is here, is z equals the value subtract the mean value divided by standard deviation, and x minus mu divided by sigma. Okay, so let's take a look when terminology that is standard score, and we could call it z-score. Okay, z-score. That represents the number of standard deviation a value x lies from the mean value. Okay, lies from the mean value. And the most important thing is I want you guys memorize this formula. That is what? That is the entry subtract the mean value divided by the standard deviation. And as we can see, here we use the mu and sigma. That means we calculate the z-score for the population, okay? Because we use the mu and the sigma. Now let's take a look at an example. Through this example, I'm gonna teach you guys how to use this formula to calculate the z-score. The mean speed of vehicles along strength of highway is 56 miles per hour with a standard deviation of 4 miles per hour. You measure the speeds of 3 cars traveling along this stretch of highway is 62 miles per hour. $47 miles per hour. And 56 miles per hour. Find the z-score that corresponds to each speed. Okay, so let's take a look at this problems. Of course, I would like to put the formula here, so in case you need it. Now let's take a look. The mean speed of vehicles, the mean speed of vehicles is what? Is mu, right? It's very straightforward. So we know the mean speed of vehicles, that means the mu here. Okay, mu equals 56. And another keyword is what? Is standard deviation. Okay, so that means sigma equals 4. Right, sigma equals 4. Okay, after you get the mu and the sigma, the left work gonna be plugging mu and a sigma to calculate the z, right? So let's take a look. The first one, z equals, the first one, we're gonna use the formula, right? Use the formula. And the first entry, I want you guys calculate the 62. So we plug in 62. Mu is what? Mu is 56, the mean value, the mu, 56. And the standard deviation here gives you 4, right? That's it. So that's the first z-score corresponding to 62 miles per hour. Okay, this guy. So we have what? We have 1.5. Here's a 6 divided by 4, going to be 1.5. Okay, now, how about the second one? The second one, how to calculate this guy? The same things. Z2 Okay, V2. Now the X gonna be a 47. Or you can put the formula again. 47, right? So X gonna be a 47. Subtract the mu is 56. Divided by what? Divided by sigma. Sigma is 4. Okay. And you can use your calculator. You're gonna get negative 2.25. Okay. So for the Z-score, you can get a negative value. It's not necessarily always positive. Okay. Now try the third one by yourself. Calculate the Z-score for 56 miles per hour. Okay, I'll give you guys roughly 1 minute. Try it. Okay, I'm gonna try it on board. So for the last one, the same things. We just needed to plug in. That is 56 minus the mu is 56 divided by 4 equals 0. Okay, equals 0. And I'm gonna give you guys the last example. Let you guys try it. The monthly utility bills in a city have a mean of $70 and monthly utility bills and standard deviation of $8. Find the Z-score that corresponding to utility bills of $60, $71, and $92. Okay, calculate the z-score corresponding to these three. Okay, now try it. I give you guys about 2 minutes or 1 or 2 minutes. Try it. I think it should be easy, right? Okay, let's do it together. I think it's not too tough. Not too tough. Let's do it together. So the first things you guys should notice that we have a mean value $70, right? So that's the mu, that's the sigma, right? That's the mu, that's the sigma. So now we're gonna calculate the z-score. X minus mu divided by sigma. And X is what? 60. Mu is what? 70. Divided by sigma, 8. Right? And we're gonna get, this guy gonna give you the value is negative 1.25. Okay, so that's the first z-score. And the second one, we're gonna have 71 minus 70 divided by 8. Divided by 8. And this guy gonna give you 1 divided by 8 equals 0.125. And the third one, we're gonna calculate the 92. The same things. Plug in 92, subtract the mean divided by sigma. That is 22 divided by 8 equals 2.75. That's it. Okay. So I think it's not too hard as long as you understand the meaning of the z-score. The mu is the mean, and the denominator is sigma, right? Sigma. Plug in these two, and then you can calculate all the z-score for each x value, right? X value. That's it. Now let's continue. Today we're gonna learn some different things. Probabilities. We're gonna go to chapter 3.1. Okay, 3.1. Basic concepts of probability and counting. Probability and counting. Probability experiment. Experiment is an action or trial through which specific results are obtained. Okay, the result of a single trial in a probability experiment is an outcome. Probability experiment. We call it is an outcome. Okay, outcome. The set of four possible outcomes of probability experiments. Is the sample space. An event is a subset of the sample space. It may consist of one or more outcomes. Well, a lot of words. Okay, so let's take a look. The first terminology that is probability experiment. Right? Experiments. That is a trial, TIL, an action or trial through which specific results are obtained. So probability experiment, we did a lot of things like we throw the coin, right? Throw the coin, head or tail, head or tail. When you watch the NFL at the beginning, two teams gonna play the coins, right? Coins. So you can choose the head or tail. And that's probability experiment. Now, let's take a look. The result of a single trial, we call it outcome, okay, outcome. And if you throw the coins for several times, for example, with several times, you can get all the possible outcomes, okay? The set of all possible outcomes, we call it the sample space, okay? The set of all possible outcomes, we call it sample space. And now let's go to the event. I'm gonna give you guys a more detail about the events. Usually, events are often represented by uppercase letter, such as A, B, and C. An event that consists of a single outcome is called a sample event. Okay, so that's the definition of the event. Event, first of all, event is a subset of the sample space. So what it means, you got a sample space and just pick some of them, okay, from sample space. It may consist of one or more outcomes. And usually events can be represented by the capital letter like ABC. And our event consists of a single outcome. We're going to specialize it. We call it as a sample event. Okay. Now I'm going to give you guys an example, and I wish through this example going to help you guys go through all these terminologies. Okay. So let's take a look. The first example. A survey consists of asking people for their blood types. Okay, as we know, the blood types can be O, A, and B, and AB. including whether they are RH positive or RH negative. Determine the number of outcomes and identify the sample space. Okay, now let's take a look at this example. So for this example, we have two scenarios. The first one is about blood types. Okay, another scenario is about they have RH positive or RH negative. Okay, we have two scenarios. So what we're gonna do is we draw a picture, we draw a diagram. Okay, we draw a diagram to do the analysis. So the four things, we draw the first scenario, O, A, B, A, B. Okay, we got these four types. And for each blood type, we have two cases. That is RH positive, RH negative. I just use positive or negative. Okay, RH positive is plus, RH negative is minus. Okay, I use plus and negative, plus or minus to represent positive and negative, respectively. And for the A case, we still have positive, negative. For B case, we have positive, negative. Okay, so now the outcome. For each try, we have outcome. Outcome for O type blood, we have O plus. Okay, and for this case is O minus. And here is A plus, A minus, B plus, B minus, AB plus, AB minus. So these are the outcome. These are outcomes, okay? And now, based on definition, the sample space is the set of all possible outcomes, okay? All. So now we can say the sample space is what? The set of all possible outcomes. So we just list all the possible outcomes. Of course, right? List all of them, okay? Include all of them. So here is a set. We use this bracket, okay? This bracket include all of them. Now let's take a look at the event. Okay, the event the outcomes with all type blood type O, blood type O. Okay, so that's the event. Now we're gonna use the capital letter, as we said before, the events are often represented by an uppercase letter, such as A, B, C. Okay, so here I can use, because I already used the A, B, O, so I can use a C for the event. And the event, let's take a look. The outcomes with broad type O. O, right? O. So how many we have with O? Is this guy and this guy, right? So event C is O plus and O minus. Okay, so that's the event. That's the event. So we have these two outcomes satisfy this event. This event. Now, the event outcomes with, for example, RH positive. Now try that by yourself. Describe the events that outcomes with RH positive. Try this one for me. Enough? Okay, so let me write down the answer. So to satisfy this event, the outcomes with RH positive. So that means which one? Positive, 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 right? So we just pick the case of the outcome that satisfy this event. O plus, A plus, B plus, or AB plus. Or you can pick it from here. O plus, A plus, B plus, AB plus. Okay, so we can write down this event right here. So we use capital letter. That is what? That is O plus, A plus, B plus, AB plus. Okay, so that's the event. That's the event. Okay. Now let me try another one. The event write down the event. The outcomes not including, okay, not including RH positive. Okay, now write down this guy for me. the event with outcome not including RH positive. Not including, okay? Do you get it? It's very simple, right? Now let's take a look. Not including RH positive, that means we have no positive, right? We have no positive. So the left is gonna be O minus, A minus, B minus, AB minus, right? That's it. So we have A, B, C, D, E. Let's write it down. O minus, A minus, B minus, AB minus. Okay, that's it. Now I'm gonna give you guys another example. Example 2. Consider probability experiment that consists of tossing a coin and then rolling a six-sided die. Okay, so when you're tossing a coin, there are two possibilities. One is head, another one is tail. When you rolling a six-sided die, how many cases we have? We have 6, right? The die could be 1, 2, 3, 4, 5, 6. Okay, so we have 2 scenarios. One is tossing a coin, and then we have these 2 possibilities. And another one is 6-sided die, gonna be 6 cases. So now I want you guys draw a diagram like that. List all the possible sample space. The first thing I want you guys find the sample space. Okay, for this case, very similar like that. Draw the diagram, find the outcome, and then we can find all the sample space. Okay, try it by yourself. Okay. Follow the example. The first example. Draw this diagram. Okay. Okay, I'm gonna write down the answer on board. So let's draw the diagram. Okay, so we have H and T, the first case. For each case, H and T, we have 6 cases. So for H, 1, 2, 3, 4, 5. Oh, sorry. 1, 2, 3, 4, 5, 6. And for the T, we have 6 scenarios. 1, 2, 3, 4, 5, 6. Okay, so I have 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay, we finish the diagram, right? Including this probability. Okay, including these 2 experiments, tossing a coin and rolling a 6-sided die. Right? Then we do the combination. So H1, H2, H3, H4, H5, H6, T1, T2, T3, T4, T5, T6. Right? And that is outcome. Okay. Now, based on definition, sample space is going to be the set of all outcomes. Just combine these together, right? So, sample space H1, H2, H3, H4, H5, H6, T1, T2, T3, T4, T5, T6. That's it. You got the sample space, right? Sample space. Now, event. The event tossing heads and rolling a 3. Okay, so for this event, we can easily write down A equals what? Tossing a heads. So tossing a head is H. Right? It's H. And rolling a 3 is this guy. Is H3. Right? Very sorry. H3. Right? H3. Now, the second event. This time I'm gonna let you guys try it. The event tossing tossing heads. Okay, and rolling an even number. Now try this one for me. Do you get it or not? about it. Tossing heads. Right? Rolling an even number. Even number is a 2, 4, 6, right?
Yeah, it's very possible.
Mm-hmm. Think about it. Okay, I'm gonna write down the answer for you guys. So tossing a hands, that means edge. Right? Even number, that means 2, 4, 6. Right? So the outcome gonna be edge 2, edge 4, edge 6. So edge 2.
Oh, so you just write them out.
Yeah, just write them out. That's the event. Event means choose all the outcomes that satisfy this condition, right? That's the definition. H2, H4, H6. Event. Now I'm gonna give you guys another example, another one. The event tossing tails and rolling a number greater than 3. Okay, try this one for me. Tossing tails and rolling a number greater than 3. Try this one for me. Should be very easy, right? So tossing a tail, C. So it should be T. Okay, greater than 3 should be 4, 5, 6. So it should be T4, T5, T6. T4, T5, T6. Okay. Now the last one. Okay, the last one. I wish everybody gonna make it. The event tossing heads and rolling an odd numbers. Okay, try this one for me. It's gonna be the last one. I think it should be very straightforward, right? Very, very straightforward. Tossing heads, that is H, and rolling an odd number. Okay. Now I'm gonna write down the answer for you guys. D, tossing heads, H1, H3, H5, right? Odd number. Okay. So time's up. Okay. I'm gonna wrap it up class here.